Okay, we are starting chapter 4 today. The topic that's covered in this chapter, or the focus, is on quadratic functions. And so what we're going to be doing today, and there are actually 2 notes pages to this, and we're going to be kind of skipping around and covering both of these notes pages here today. We're going to be focusing on how the graphs of quadratic functions look, and then how to, like, some of the different parts of that graph, the vertex, how to calculate the vertex axis of symmetry, things like that. Okay, so first and foremost, when we are talking about a quadratic function, you need to be able to recognize when you look at an equation, if in fact that equation is a quadratic function. And so the distinguishing factor for that is it has to be an equation where the greatest exponent, okay, on your variable is in fact a 2. Okay, this is typically the generic way that we write quadratic equations: ax squared plus bx plus c. That's in descending order, but there would really be numbers in place for this a, b, and c. Okay, so what we're going to do in this first example is we're going to go ahead and see if we can graph this particular quadratic equation. And we're going to make a table of values, and we're going to be using our calculator to help us with this. Okay, so what I'm going to ask you to do is get your calculator out. If you would, please, go ahead and press the y equals button. Now, I want to bring a couple things to your attention here with what's on my calculator screen. Of course, if you have any old equations, as I do here, stored in y1, you would want to clear those out, okay? The other thing that you would need to do, see how this plot 1 is darkened? That means I have a scatter plot, or I have some graph in my stat plot turned on. A quick way to turn off any scatter plots that you might have would be to actually just move the cursor on top of that darkened plot 1 and press enter, and then move the cursor off, and that's a quick way to kind of turn off that scatter plot. Okay, what you're going to do now is you're going to enter in the equation 3x squared minus 12x plus 6. Okay, now our goal here is to graph this. Not so much on the calculator. We want to be able to pull some points off of this graph to write down on our notes page here, and then we're going to plot it by hand on the grid that is on your notes page. But I'm going to go ahead and have you press the zoom button on your calculator, and then I'd like for you to select option number 6, titled Z standard. We know that would graph the parabola, is what quadratic graphs are called, in a window from -10 to +10, okay? Now, sometimes a window from -10 to +10 is not a good window, but here we can kind of see the graph at least. Okay, what I'd like for you to do, though, is I'd like for you to go ahead and go into the table. If you would, go into table setup first. Make sure that we're starting our table out at an x value of 0. Then go into the table by pressing second and the graph button. And what you have here is you have all kinds of points that lie on this parabola. Now, you can scroll up or scroll down to get some different points, but you'll notice how my y values are starting to get really large. I need you to pick 4 points that you are seeing in this table here that would allow us to plot it over on the graph, and then we can run our pencil through it. So I'm going to try to pick things that I could easily graph. So I don't want to make these too large because my grid isn't very big. So I might, just starting at the point 0,6, I might write down 0,6, 1, -3. I'm going to write down these first 4 here. Okay, so I'm going to switch back to our notes here. Okay, and I'm going to go ahead and fill in the table. Whoops, that was not a -6, it was a +6. Okay, so I'm going to go ahead and fill these in. And then I'll just come on over and I'll just plot these 4 points. Okay, that gives me a good enough sense of sort of how to run my pencil through those to construct the graph. Okay. All right, so you can see I kind of did the same thing here for the second graph there for you already. Okay, I just want to talk briefly here about the parts of a parabola. There's some terminology here that you want to make sure that you are familiar with. Okay, the first term is called the axis of symmetry. And what the axis of symmetry is it's a vertical line that runs right down through your parabola, and it cuts the graph in half. You can see that pictured right here in red, the axis of symmetry. Okay, you'll notice that what the axis of symmetry does is it goes right through what we call the vertex of the parabola. And that vertex is basically where the U-turn occurs on your parabola. Okay? Now, there is a formula for the axis of symmetry. Okay, if you are given an equation of your quadratic function and you want to calculate what the axis of symmetry is, what you will do is you will take negative b and you will divide that by 2a. Now, when I say b and a, what I'm referring to are these constants. The b is the number in front of the x, and the a would be the number in front of your x squared. Okay, so you're going to do negative b divided by 2a, and notice that this formula has an x equals in front of it. That's because when you write the equations of vertical lines, which is what an axis of symmetry is, those equations are always x equals. Okay, now when we go to find the vertex, and at some point here soon, we will use the calculator feature to find the vertex, but for right now, and on your homework assignment tonight, this is how I want you to find the vertex. Okay, you're going to use this formula. The formula is that the x-coordinate of your vertex is found by doing, oh, this looks familiar, negative b over 2a. Well, that was the same exact formula for the axis of symmetry. Okay, and that's not a coincidence, because if this axis of symmetry is running through the x-coordinate, the x value right here, then that same x value is also the x value of your vertex. Okay? Now, when you're using these formulas to get the coordinates of the vertex, okay, you always have to find your x-coordinate first. Because what you will do next to get the y-coordinate is you will take your answer, negative b over 2a, and you will calculate what we say f of negative b over 2a. So in other words, what you will do is you will take this number for the x-coordinate of your vertex, and you will substitute that value into your equation, into your function for all of the x's, and what you get back out is the y-coordinate of your vertex. We're going to practice this, but on your assignment tonight, this is how to find the vertex, and this is what I want you to do. I do not want you to use your calculator to find the coordinates of the vertex. We will do that, and we will do it soon, but on all of these problems, you need to be using this formula. Okay, before we look at a problem here, let's just take a look at a couple other terms here. The y-intercept, of course we know the y-intercept would be where the parabola is crossing the y-axis. What's common about all y-intercepts is that the x value is 0. So you will notice here that you will find the y-intercept by taking your equation and substituting a 0 in for the x's, okay? And whatever you're left with, which by the way would always be your c value, that is your y-intercept. Okay, finally, the term roots is just a synonym for x-intercepts. We know that the x-intercepts, at least on this picture, would be these two places here. That is what we refer to as the roots. And we will be using our calculator to get those x-intercepts at a later date here, okay? So let's flip to the back and see if we can kind of work through finding each of these different elements here that we discussed on the front. Okay, here you can see is our equation. Okay, the problem is asking us to come up with the y-intercept. Okay, if you recall, the y-intercept is found by substituting a 0 into your equation for all of the x's. That leaves us with a -3. I'm going to write it, though, as a point. It would be at the point 0, -3. So I'm going to go ahead and just plot that on our graph here. 0, -3. Okay. All right, so that's our first step. Okay. The other thing we're asked to do, AOS, I'm abbreviating AOS for axis of symmetry. Okay, when you write the axis of symmetry, you always need to make sure that you include an x equals in front, because axes of symmetry are equations of vertical lines. Okay, if you recall, the formula for the axis of symmetry is -b over 2a. So what I'm going to do over here to the side is I'm going to do negative, and then look at what the b value is. That's this 4 here. So I'm going to do -4 divided by 2 times a. Now the a is this number in front of the x squared. If you don't see one there, we know that's going to be a 1. So this is going to simplify to -2. So my equation for the axis of symmetry is x equals -2. That means on this graph, the very middle slicing through the parabola, this would be my axis of symmetry, right through where x is -2. Okay. Now, it's also asking us to come up with the x-coordinate of the vertex. Well, the benefit of having already calculated the axis of symmetry is that whatever value that is also what the x-coordinate of your vertex is, because it's the same formula, -b over 2a. Okay, to get the y-coordinate, what you will do next is you will take the value you got for the x-coordinate, and you will now substitute into the original equation for the x's the x-coordinate of your vertex. So I'm going to substitute a -2 in for all of the x's in this equation right here. Okay, I'm going to go ahead and simplify that. It looks like when I do that, I'm going to get a -7 back out. It'd be very important that you are using your parentheses here. You get a completely different answer if you just type in -2 squared versus if you type in -2 in parentheses squared. Okay, and then the y-coordinate of my vertex is -2, -7, and I'm going to go ahead and plot that. So -2, 1, 2, 3, 4, 6. Okay, so there's my vertex. Okay, and then to finish this off, it says make a table of values. That's the same thing that we did on the front. So what we're going to do then on our calculator, and I'm just going to switch back here, is we're going to clear that equation out of y1. We're going to go ahead and type x squared plus 4x minus 3. And I'm going to go into the table. I'm going to start it back out at 0, just as a starting point here. And I just want to pick 4 values from this. Some of these ones over here are going to be a little easier. So I might choose, did I type that in right? Let me double check this. X squared plus 4x minus 3. Okay, that looks good. Okay, so I'm going to go ahead and write these down. I'll just maybe, I guess we have 5 places here in this table, don't we? Okay, maybe I'll start here, and I'll just, you can pick whatever would be easy to plot. You have a variety here, but just choose 5 of them, okay? So I'm going to go ahead, and I'm just going to fill in -3, -6. This one was my vertex, if you remember, okay? There's this point, and that one, and that one, okay? And I'll go ahead and just quickly graph these. 2, 3, 4, 5, 6. I think that goes there. That one, and there's the other one, okay? And then I will run my pencil through that to get the graph, okay? If you got the idea of how to do that, I'm going to go ahead and skip example 4 so that we can move on to the bottom of this and then also do a few problems on the next notes page. Okay, what we're looking at here in this box is how you can tell which direction your parabola is opening, if it's opening up or if it's opening down. And what dictates that is your lead coefficient. If your a value is greater than 0, that means that the parabola is opening up, okay, so think of your graph that's opening up, but then if it's opening up, that means that your vertex would be a minimum, okay? So if it's opening up, we would classify the vertex as being a min. As opposed to, if your A value is negative, that means your parabola is opening down, which then means that your vertex is now classified as a maximum. And you can kind of answer these questions not by looking at the graph, but just by looking at the equation. Okay, so let's look at example 1 here underneath number 5. It says, first of all, just determine whether the function has a max or a min. Okay, so what we would do is we would look at the A value, and I would see that it is less than 0. That tells me that I know the graph is opening down. If it's opening down, then I'm going to classify the vertex as being a maximum. Okay. Now, when it says here in part B to state the max or min, what they're wanting is they want us to give the coordinates of the vertex. So what's very important, and this will be relevant when we go to the next page here, anytime a problem is asking you to come up with a max or min, they're really just wanting the vertex. And if you recall, we're going to find the x coordinate of the vertex by doing negative b over 2a. And then we're going to find the y-coordinate by plugging that negative b over 2a value into our function for all the x's, and that'll give us the y-coordinate. So that's what we need to do for part B here. Okay, in part B, I'm going to off to the side do negative b, that'd be negative 12, over 2 times a. I'm going to simplify this. Looks like this is going to simplify to 3 halves. So 1.5 or 3 halves is the x coordinate of my vertex. I'm now going to plug 3 halves into the equation for all of the x's, and I'm going to see what I get back out for the y-coordinate. Now I want to show you a really great feature on your calculator for something like this. So I'd like you to back out of this screen on your calculator, just go into the home screen here. Okay, when you're making a substitution, especially fractions or negative numbers, like we're plugging 3 halves into our equation, there is this awesome feature called the store feature. Okay, here's how this works. You're going to type first the number that you're going to substitute. So 3 halves is our number, and then you're going to press this black STO button that's on the left. Okay, and then after that, you're going to select this button that's going to give you the variable x. Okay, what we're doing, and hit enter please, is we are now saying, look, anytime we use an x in just this home screen, this doesn't affect when you type x's in the y equals screen. Okay, but in this home screen, anytime you type an x, you have now stored the value 3 halves in for it. And so what we can do now is we can go back to the equation, negative 4, and I'm just going to type an x here, x squared, plus 12x plus 18, and the calculator's doing all the dirty work of substituting the 3 halves in for me since I stored a 3 halves in for the x. And I can see that this eliminates all the parentheses and me having to type in 3 halves multiple times. I can see that the y value that I would get back out would be 27. So I get a 27 for the y-coordinate of the vertex. Okay, then it says on part C, we want to state the domain and the range for this function. Okay, I think what you're going to find valuable is to draw just a miniature picture, almost like I did right here, to go ahead and label once you have the coordinates of the vertex, kind of label that on the picture. And I want you to think about this domain. Remember, the domain, those are all of your x's, and range is all the y's. When you're talking about a parabola, the parabola stretches to the left forever. It's very, very gradual, it's very subtle, but this parabola is technically forever getting wider and wider and wider on both sides. And it will continue to get wider and wider and wider on the left and on the right. So all of these parabolas, the domain will be all real numbers, or if you prefer, you can write it from negative infinity to positive infinity. However, on a parabola, the graphs do not go down forever and up forever. They only go forever in one direction. And so you can see here that this is going down forever, but it's not going up forever. So the lowest y value is a negative infinity, but the highest y value would be a 27. So I want to say, we start with your lowest. I want to say the lowest y value is negative infinity. The highest y value would be at 27. And that's what you would state for your range. Okay? All right, we're going to go ahead and skip this other one. It is just like this in terms of what you would do to work through that process. And what I'd like to do now is we're just going to put what we just learned in action in just a couple of word problems here. Okay? So let's go ahead and look at this example here on the front. Okay, should be a good one for us to look at. And all I have here is just a quick review. Remember, the coordinates for the equation for the x coordinate of a vertex is negative b over 2a, and then the y coordinate is f of negative b over 2a. Here's the key with word problems, folks. You want to be able to read through a problem and be able to distinguish key words like the greatest, the least, the lowest, the minimum, the maximum. When you see words like that, those are all words that are really just telling you, hey, find the vertex, and then you just do these formulas here to find the vertex. So here we're talking about Maya. It says she throws a ball. We're going to this is our y coordinate is the height, and our x variable here is the time, t in seconds, okay? And here is our equation, all right? It says, what direction does the parabola open? Well, we're going to look at our a value. It's negative, and we know that means that it's going to open down. Okay. Well, if it's opening down, it says, is the vertex a max or a min? Well, if it's opening down, the vertex would definitely be a max. Okay. Now it's asking, and this one did just come out and say, hey, what are the coordinates of the vertex? Okay. So they made this one easy for you. We're going to do negative b over 2a. So I'm going to do negative 18 over 2 times negative 16. If it is a decimal, which it is, use the math fraction button on your calculator to switch it back into a fraction. So remember, this is our time in seconds. So the x coordinate here is 9/16 seconds. The y coordinate is the height that the ball reaches. That is found by taking 9/16 and plugging 9/16 in for all of the x's, or in this case, in for all of the t's. Okay, I would encourage you again to use the store feature. Okay, you're just going to go back onto your calculator. Okay, you're going to type in 9/16. You're going to hit the store button and the x and hit enter. Now, anytime you use an x in this screen, it thinks there's a 9/16 stored in it. And so then you would go back and you would type the original equation into your calculator, negative 16t squared plus 18t plus 4. Switch that back into a fraction if you like. That comes out to 145 over 16. That would be in feet. 145 over 16 in feet. Okay. Okay, now here, they're going to use some words like, what is the highest point reached by the ball? When they use a phrase like highest or maximum, they're really just asking for part of your vertex. So you have to ask yourself, is this asking for the x coordinate of the vertex or the y coordinate of the vertex? But that word highest and maximum are buzzwords that mean vertex. Well, if it's asking about the highest point that it reaches, it's talking about height. It's not talking about time. So this is wanting the y coordinate of my vertex. Okay, the y coordinate of the vertex is the 145/16. Okay, if you prefer, you could round that to 2 places and say that it's about 9.06 feet. Okay. Down here in part E, it says how long is it taking the ball to reach its maximum height? Now the question here is it wants to know a time. So this is asking for the x coordinate of your vertex, which we have already calculated that to be the 9/16 seconds. If you prefer, you can write that as a decimal, 0.56 seconds. Okay. All right, so I'm just going to fill in this last one here very, very quickly so that you have one other word problem kind of filled in here for you. This is talking about the cost of manufacturing X lawnmowers. So we are going to let X be the number of lawnmowers and Y is the cost. Okay, the question, what direction does the parabola open? I'm looking at the A value. I see it's positive. That tells me this is definitely going to be opening up. It wants to say, okay, is your vertex a max or a min? Well, if it's opening up, the vertex is definitely a min. What are the coordinates of the vertex? That's going to be negative b, so I've got two negatives in a row there, divided by 2 times a. That comes out to exactly 2.5. That would be mowers. Okay, I don't think anybody's making half a mower, but we're going to fill this in here. 2.5 mowers. And then to get the y coordinate, you're welcome to use the store feature. I would encourage you to do it. You could go back onto your calculator. You could store 2.5 in for the x, and then type the original problem in with the x's, and it should give you the y coordinate for this is roughly $74.95. Remember, the y was the cost. $74.95. Okay, now here's some buzzwords here. It wants to know what's the minimum cost reached by the company. Okay, minimum, that's a word that means vertex. Okay, there's that word minimum again, vertex. Okay, but what part of the vertex is it asking for? Is it asking for number of mowers, or is it asking for cost? Well, this was asking for cost. So we're just going to report the y coordinate of the vertex, the $74.95. Here it wants to know, oh, what's the number of lawn mowers? So it's asking for the x coordinate that would produce the minimal cost of the vertex here. So number of lawnmowers, we're going to go ahead. Now, you can report 2.5 if you want. It's also acceptable if you want to go ahead and either round down or round up to the nearest mower. Okay, I would accept any of those. Okay, 2.5 doesn't entirely make sense, but that also is the very lowest point, or you could say 2 or 3. Okay, because it kind of straddles those two numbers there. Okay.